All right, so we're looking at page 130 in our notes. This is also section 5.2. And so I want to revisit again what we just talked about a minute ago as far as when we're taking square roots. So we had this problem in our warm-up. So it's the square root of -3 squared. And we said you'd have to square this -3, and that gives you +9. And then the square root of +9 is 3. So that brings us to this problem. What if I'd had the square root of x squared? Do you notice how in this case x was negative, but what did our answer have to end up being? Positive. So if I have the square root of x squared, that answer would just be x, but I can't call it x because it has to be positive. X can be anything. It can be negative, positive, whatever. So how can I say that this always has to be a positive? Yeah. Absolute value, you are correct. So anytime I'm taking the square root of x squared, I have to write the absolute value of x. So what about this problem we had? We had the cube root of -3 cubed. -3 cubed was -27. And what was the cube root of -27? Was it 3 or -3? It was -3, wasn't it? So the cube root of x cubed is x. Do I have to say that it's always going to be a positive answer? No, it could be a negative answer, couldn't it? Just right here, this was a negative answer in our warm-up problems. So let's take this a little bit further. What if I had asked you for the cube root, or I'm sorry, the square root of -3 to the 4th? Does anyone know -3 to the 4th, what that is? 81, good. So now I'd have the square root of 81. That answer is 9. So now what if I had the square root of x to the 4th? What's that answer going to be? X squared. But guys, what's always going to be true if I have x squared? It's positive. So do I have to say absolute value? It's going to be redundant to say that because I already know that this is going to be a positive answer. Okay, so let me show you one more case where I would have to use absolute value. So what if I had to take the 4th root of, say, x to the 12th? Well, I can think of that as x to the 12 over 4 because this is my power and this is my root. And what does that end up being? X to the 3rd. But I'm taking a 4th root. Anytime I take a square root, a 4th root, a 6th root, an 8th root, they always have to be positive. So would I have to use absolute value here? Yes. So when are we going to worry about absolute value? When to use absolute value? There's really only 2 conditions that must be met. First of all, what kind of root is it going to have to be? Even root. And what else? This one I didn't have, this was an even root, but I didn't have to use absolute value. This was an even root and I did, and this was an even root and I did. Yep, very good. An even root with odd power. That's the only time I have to use absolute value. I'm going to tell you right now, in a lot of books, Algebra 2 books, they'll say, assume that all variables are positive. And that's because they don't want you to have to think about when you need to use absolute value. Well, we're going to think about it because this is Honors Algebra 2 and you need to understand it. So in some of your homework problems, it says, assume all variables are positive. I don't want you to do that. Anytime you've taken an even root and your answer has an odd power, you need to use absolute value because of these situations we referred to. Okay? All right, let's go over here now to our back page of 132. These are the only 2 problems we have to finish up. Notice right here, your directions say assume all variables are positive. We're just going to cross that right out, and if we need to use absolute value, we're going to use absolute value. So let's look at number 15. We've got the 4th root of x times the 4th root of 81x. We're all different. Some people think better in radical form. Some people are better with rational exponents. But one thing we should all be able to do is if we have a perfect square or cube or 4th power, we need to go ahead and do that. Is there a perfect 4th root of 81? 3. So I'm going to go ahead and do that right away. So I've taken care of this. Now I still have the 4th root of x times the 4th root of x though. Okay, down here, the 4th root of 16, is there a perfect 4th root? 2. And I still have the 4th root of x to the 36th. Now, at this point, I like to convert into rational exponents. I think it's easier. So I have 3x, I'm going to have x times x, that's x what? Squared. But what root are we taking of both of them? 4th. And I can only combine them if they have the same root. If they don't have the same root, then I would have to do a little more work with that. And then on the bottom, we have 2x, the power's 36, and the root is 4. And now I just want to simplify this. So if I have 2/4, what's that? 1/2. And then 36 over 4 is 9. So this would be in simplest rational exponent form. Most of the time, I'm going to ask you to write it in simplest radical form. So try that. How would it be in simplest radical form? Anybody know? How do I write x to the 1/2? Radical x, right? So I'm going to have 3 radical x over 2x to the 9th. And I'll tell you there's an absolute value needed here somewhere. Do you know where it would be? On the bottom. Do I have to put 2 in absolute value? No, it's already positive, isn't it? I would never put positive an absolute value on that. But right here, I would have to have absolute value. Here's the reason why. I was taking the 4th root and I ended up with an odd power, right? So this could be a negative answer, but based on the fact that if I take the 4th root, I have to get a positive answer, I have to say that this has to be a positive. Okay? This is the best answer. I will ask for radical form most of the time. Your book doesn't state it, but it needs to. Go ahead, Hannah.
So like on the homework, we have odd ones. Will it show it in this form or not? Say assume that it's positive.
In the directions when it says assume positive variables, they do not use absolute value there. And I think there were only there were 2 in the book that I had to change my answer key to because they said assume positive variables, and I don't want you to ever assume that. Yep. This is rational exponent form. And this is radical. Rational, remember rational means fractional. So you can think whenever I use fraction exponents, that's using rational exponents. Okay, let's look at the next one. See, these problems look really complicated when you first look at them. The way that I always approach every problem is I like to get rid of negative exponents first. Does anyone remember how I can get rid of negative exponents? Yep, just move where they are. If they're on the bottom, take them to the top and they become positive. If they're on the top, take them to the bottom. So that's what I do first. So I'm going to keep my 21 the same. This I'm going to take down to the bottom, and this I'm going to take up to the top. So if I take the 7 to the top, it's positive. Take this to the bottom, and now it has a positive exponent. This one stays where it is, and I'm going to write it as y to the 1/2. This one stays where it is. This is going to stay where it is. This is a negative, so I'm going to take it to the top to make it a positive. And that's a positive. So it stays where it is. Take a look at that for a minute. Stayed, moved. stayed. Oh, did I write that wrong? That's 5 halves? Yeah, 5 halves, sorry. And that moved. Okay, and I always like to double check for that reason. I just didn't see that exponent was a 5. All right, so now I have everything in positive form. So I want to look for anything that matches that I could just cancel out on top and bottom. I don't really have that. But I can do 21 times 7, that's 142. Now these y's, my bases are alike, so I add the exponents. So what's 1/2 plus 1/2? Just 1. So I'm just going to have y to the first. Okay, my z, I'm just going to leave it as z to the 5 halves for now. We'll go back to that in a minute. These bases are alike, so I have to add my exponents. What's 3 halves plus 1/2? Which is 2, so I'm going to have x squared on the bottom. And then my z. Well, I'm not completely simplified if I have a z on top and a z on bottom. What do we do if we're dividing and our bases are alike? What do we do with the exponents? Subtract them. So I'm going to come up here, and I'm going to have 142y. If I subtract, I'm going to have z to the 3 halves, and then x squared, and then that z is now gone because I subtracted. And so the last thing I'm going to do is I want to write this in radical form. So if I have z to the 3 halves, I'm going to think about what that means. That's the square root of z times z times z, because it's z to the 3rd. That's z times z times z. So right here, I have z squared. So what's the square root of z squared? Just z. So here's my answer then. 142y z radical z over x squared. And now I have to look back. Was I taking even roots? And I was. So I have to check to see if anything is to the odd power. Are things to the odd power? Which variables are to the odd powers? Y and z both. So I'm going to have to put both of those in absolute value because those were even roots originally and they're being raised to an odd power, so those are going to need the absolute values. Okay? So what kind of root would you like to work with a little more than evens? Odd. Because if you have an odd root, you don't have to go back and worry about absolute value. But if you have an even root, you have to go back and check. Okay? Any questions about that? All right.